Physics 30s, Mr. Thompson here again. This marathon of a lesson on curved mirrors and lenses. All right, page 87. Let's do a couple more here. Let's do question number 8. So an object is placed 21 centimeters in front of a concave converging mirror. If the image is real and 4 times larger than the object, then find the distance to the image. Okay, so what we have here is we have 21 centimeters, would be DO. Image is real, 4 times larger. Now, real images are always inverted, so the magnification here would be -4. Okay? I want to know the distance to the image. Well, the magnification is -DI over DO, and we have DO right up here. And so for part A, DI would be 4 times 21, which is 84 centimeters. All right, part B, the mirror's focal length. Well, 1 over F equals 1 over DO plus 1 over DI. And a little calculation here. (16.8), and so that would mean that F is 17 centimeters. All right, question number 10. Let's try that one. An object is placed 17 centimeters in front of a concave diverging lens. If the image is 20% of the size of the object, then what is the lens's radius of curvature? Okay, 17 centimeters, that's where the object's placed. I got that. Image being 20%, well, this is a diverging lens, virtual image. That means that the image is going to be upright, and so the magnification would be a positive 20% or 0.2. That's -DI over DO. Well, from this, we can have DO right there. We can figure out DI. DI would be equal to -0.2 times 17. Okay, and let's do the calculation. Try it out. Lights go out faster and faster every time, it seems. I get -3.4. Okay, now I can go ahead and find my focal length. I want the radius of curvature, so I better start with the focal length here. So 1 over DO, which is 17, plus 1 over -3.4. And so I'm going to figure out this focal length. So 1 over 17 plus 1 over -3.4, invert that, -4.25. So the radius of curvature would be 2 times that. So multiply by 2. Oops, not by 8, by 2. -8.5. Okay, wonderful. Let's try maybe one more problem here. Let's take a look at question 11. Okay.
Adam, if you're in the building, when you get a minute, please come to the office. Thank you.
Well, there's GT right there. Okay. All right. Heard his voice many times. All right. It says here, a converging convex lens has a radius of curvature of 40 centimeters, virtual image produced 18 centimeters tall, 50 centimeters from the lens. What is the height of the object? Okay, lots of stuff going on there. All right, so let's break it down here. We have a converging lens, and it has a virtual image. Okay? All right, so in the case of the radius of curvature, I know the radius of curvature, of course, is 2 times the focal length, and so the focal length would be half of the radius of curvature, which is half of 40. So 40 over 2, which is 20. Now, because it's a converging convex lens, it's going to have a positive focal length. Okay, so I'm leaving it as positive 20. Okay, next thing I want to do here. I noticed it's a virtual image. It's 18 centimeters tall. Virtual images are always upright, and so the h for the image must be equal to positive 18. The distance the object is from the lens, pardon me, the image is from the lens, because it's an image, right, is 50 centimeters. Now, of course, you can see that this is a virtual image, though. So the height of the image is upright, but the image distance would be a negative. Okay? This is an idea of interpreting these signs properly. So negative 50 centimeters. All right, now I have f di. What I want to do is I want to figure out what do is. That's the only way to kind of get this thing finished up. So I'm going to go ahead with my thin lens formula. 1 over f equals 1 over do plus 1 over di. I'll put in what I have here. 1 over 20 equals 1 over do plus 1 over negative 50. And figure out what do is. So I have 1 over 20 plus 1 over 50. And I get 14.2857. Okay, so that helps a little bit. Now what I can do here is I can use my formula. Hi over ho equals negative di over do. Now I look here, I have essentially all the information, but ho, that's the one I'm looking for. So I'm going to substitute in what I have here. I have 18 over ho is equal to a negative 50 over 14.2857. All right, so let's go ahead and do our solution. I'm going to multiply these two together, okay, and then I'm going to divide it by 50. So I have 14 and change sitting there, multiply by 18, and then divide by 50. 5.1. Okay, thank you very much.